Okay, this video reviews the elimination process for systems of equations, and this is using page 18 in your spiral bound notebook. And here the coefficients are not alike, so you don't have matching terms in the coefficients. You have to create that. So I'm going to do number 4 on the video, and I'm going to choose to eliminate x. That's just my choice. I'm going to eliminate the x in this problem. And if x in the first equation had a coefficient of -4, then I would be able to add -4 and positive 4x, and I would be able to temporarily eliminate the x. So that's my goal. That's what I'm going to do. And you have choices here, so this is the decision that I'm making. I'm going to eliminate x, so I'm going to take that first equation and I'm going to multiply each term by -2. So that means that the first equation becomes -4x minus 10y equaling -28. So I take the second equation and I copy it over. Did not have to change the second equation at all. And now I can simply add these terms together and the x's will temporarily eliminate. So I'm left with 8y, and that equals -32, so y is -4. Now to find x, if I go back to the original equation, I can go back to anything above it, doesn't matter. I'll just take the first equation. If y is -4, then I have 2x, and 5 times -4 is 20. Add 20 to both sides, 2x is 34, therefore x is 17. So the solution to this system is the ordered pair positive 17, -4. Let's do number 8 on the video now. Number 8. So on problem set number 8, I have to manipulate both equations. My decision is I'm going to go after the x, so I'm going to give each x a coefficient. One x would have a coefficient of +6, the other would have a coefficient of -6. So that means I need to take the first equation. I'm going to multiply the first equation by +2. So that means I have 6x minus 4y equaling -14. And I'm going to take the second equation and I'm going to multiply this equation by -3. So that means I have -6x plus 15y equaling -30. So now I could bring the two equations together and solve as before. So the difference now is you decide which variable you want to eliminate, and then you have to multiply each term in that equation by the necessary factor in order to create additive inverse. So now when I add these together, when I do the vertical addition of adding these two together, the x's will temporarily go away. I'm left with 11y equaling -44. So y is -4. And then I'll leave it up to you to find the x value. You know how to do that. Go back to either original equation, let y become -4, and the answer is x is -5. So the solution to this system is the ordered pair -5, -4, but I'll let you find the x term on your own. Let's look at number 10 on the video. So in number 10, analyzing this, once again I have no matching terms, so I'm going to go for eliminating x. So I'm going to take the first equation and multiply it by 5 because I'm going to try to give the equations alternating 20s, +20, -20 coefficients. So that means my first equation becomes this, and then my second equation, I will multiply the second equation by -4, and when I do that I have, I'll just put it over here. That gives me -20x minus 16y, and that would equal -4. So now I have my system. I have coefficients that are additive inverses. So now I can simply do vertical addition on these. X's will sum away. I'm left with negative y equaling negative 9. So that means positive y is positive 9. And now to find the x that goes with this, go back to either original equation, let y take on the value of positive 9, and you would find that x is negative 7. And I will let you all do that on your own.